All right, this is ATT Unit 1 Review Section 1D here with Mr. Johnson. This is about interpreting key features of the graph for both linear and nonlinear applications. So let's start with number one. You're on a bike ride and start off 40 miles per home. When I see that start off, that makes me think like the beginning. I think a lot about the y-intercept when I hear those words start or begin. So I'm 40 miles from home. You bike steadily home. So that's a constant rate, steadily at a constant rate, at a rate of 5 miles per hour. Note the slope will be negative since I'm biking towards home. So if we look at our d-axis here, or y-axis in this case, we're using the letter D for distance from home, right? So that distance is going to be decreasing as you're biking home over t hours. So we start 40 miles from home. So at time 0 hours at the beginning, 40 miles from home. I'm going to plot that point right here at 0, 40. And then every hour, we are going 5 miles per hour. So I'm going to get 5 miles closer to home, 35, 30, 25. And I can go ahead and plot those points, 35, 30, 25. And I'm going to keep going here until we eventually reach our x-axis or our t-axis in this point, or in this example. All right, so we've got our table there. Write an equation that expresses d in terms of t. So when I see that phrase, I know it's going to be d equals something with t in it. Well, let's think about where we started. We started at 40 miles away from home. And if we're decreasing our distance from home by 5 miles each time, we're getting 5 miles closer. I'm going to say that's minus 5t. T being our time in hours. We could also write this as d equals negative 5t plus 40. Again, your slope is negative 5, going down 5, right 1, and your starting point, or y-intercept, is at 40. Looks like we've got our equation already graphed there. Notice I don't have arrows because I don't keep going negative distance from home, and I can't go backwards in time, so there are no arrows on this graph. When are you 10 miles from home? Illustrate this as a point on the graph. Well, if our distance from home here is our d-axis, when I'm 10 miles from home, it looks like that happens 6 hours into the ride. So we'll say it's 6 hours. I'll put here, this is that point, that's 6, 10. And what is the t-intercept? Well, that is when we cross the t-axis. It's when our d is equal to 0, and that occurs right over here at 8, 0 is our t-intercept. What does this mean, by the way? Well, after 8 hours, our distance from home is 0. So that would mean you're home, right? You are 0 miles away from home. You are at home. What is the slope? Well, from our graph, we can see that we're going down 5 and right 1, down 5 and right 1. You can also see our slope in our equation, or also in our change in d each time as t increases by 1. Our d values are decreasing by 5. So that would give me a negative 5 over 1. When we talk about real world meaning, I always want to think about our units here. So we're going miles from home over hours. So what does this slope mean? We're traveling 5 miles per hour, or 5 miles closer to home every hour. So looking at those units really helps us there. 5 miles closer to home every 1 hour. All right. Looking at our question number 2 here, the graph at the right shows the altitude, A, in feet of a skier t minutes after getting on a ski lift. So we've got our a-axis, our t-axis here. Let's first look at the slope of this line. Now we could choose 2 points and calculate the slope between them. I think it might be easier to look on the graph and try and find this slope. And then we have to explain its real world meaning. Well, if I look at this table or this graph here, it looks like to find my next point, I go from, I want to say this is 150, or sorry, 100. I go from 100 up 200, 300, 400. So that's a positive change of 300 over 2. So if I think of this as 300 over 2 or 150 over 1, let's think about that units. That's feet in altitude is our y or our a-axis over minutes is our t-axis. So this would tell me that the skier gains 150 feet in altitude every 1 minute. It's always helpful to look at those units of the a-axis and t-axis there. Our a-intercept in letter B, that occurs when t equals 0, or at the beginning here, I can see that point in red. That's at 0, 100. All right, that's even then before getting on the ski lift. Before the ski lift even starts, the skier is 100 feet in altitude. So the skier starts or begins at an altitude of 100 feet. All right, the last one says to write an equation for this line. We can use either form. Slope-intercept, if we recall, is y equals mx plus b. Point-slope form, y minus y1 equals m times x minus x1. Let's do both of these. In this case, we're not going to use y and x, though. We will be using a and t. So let's start with slope-intercept form. Our a, our altitude, is equal to our slope, which we calculated at 150 times t, or x, plus our y-intercept, which we saw we started at 100. There's our equation, 150t plus 100. Starts at 100, gains 150 feet every minute. Our slope-intercept form, so instead of y, we'll do a minus something equals our slope. We know that is 150 times t minus something. And again, these could be easily replaced with y and x there. And now we just choose a point. And it doesn't matter which one you choose as long as it's clearly on the graph. How about this one here at 4, 700? This is not the only right answer, but how about a minus 700 equals 150 times t minus 4? Another example could be a minus 400 equals 150 times t minus 2 had we chosen that point at 2, 400. So again, lots of answers. All right, there are a ton of different responses here that could work. So that is section 1D. Hope that helped. Good luck on your test.